Assalamualaikum. We are from Group 1. We present about the distribute file system simulation. This is our group members. First is Nurul Amir Alam bin Zulkifli, AI220076. Next is Muhammad Syahrul Rizal bin Abdullah, AI220014. Next is Muhammad Khairul Amri bin Abdul Rahim, AI220283. And next is Amal Zamani Azim bin Ahmad Zaidi, AI220155. And lastly is Ahmad Sheridan bin Ibrahim, metric number AI220173. First of all, what is distributed file system? A distributed file system simulation is a development and implementation of a model that mimics the operation and interaction of a distributed file system in a regulated virtual environment. The purpose of this system is to order and to replicate the dynamic and features of an actual distributed file system. The simulation use software to model the key elements of the distributed file system, including the server, the client, and also the network infrastructure. The main concept of distributed file system is first, workload scenarios. This is to evaluate the system performance in a range of circumstances by creating a different workload scenarios, access pattern, and system load. Secondly is the fault tolerance. This is to present the potential failure or fault situation for nodes and, and simulate the mechanism for fault detection, recovery, and maintain the data integrity. And lastly is analysis and optimization. This is to examine the simulation result to determine distributed file system design advantage, disadvantage, and potential areas for development. We will try a variety of combination to maximize the performance. Next is the importance of distributed file system. Distributed file system simulation are important to provide researchers, developers, and also system architects with critical insight into the behavior and the performance of distributed file system. The benefit of this distributed file system is it is cost effective. We also can know the performance assessment and also the scalability testing.
My name is Muhammad Shahrizal bin Abdullah, batch number AI220014. For improvement, first, network visualization. Give an illustration of the network architecture to show how the servers are connected to one another and emphasize the channel of communications and show how information is transmitted across the network. Second, redundancy mechanism. Use the silent technique, including server replication, to ensure that the data is accessible even in the event of server outages. To recover lost data and redistribute it throughout the current server infrastructure, implement automatic recovery techniques. Lastly, synchronization techniques. Analyze a few synchronization approach to provide consistency in a distributed environment and emphasize how synchronization affects system reliability, data integrity, and performance.
For advantages, I have listed 4 advantages, which is fault tolerance, enhanced data security, high availability, and load balancing. For disadvantages, I also listed 4 disadvantages, which is complexity. What is complexity? Complexity is building and maintaining system demand, sophisticated algorithm, and also challenge in implementing consistency models and synchronization. Next, latency. What is latency? Latency is accessing geographically dispersed data may cause delays and impact on overall system responsive during file access. Next, network overhead. What is meant by network overhead? Network overhead is communication between nodes, increased network traffic, and replicating data for fault tolerance consumes valuable resources. And lastly, security concern. Security concerns is meticulous attention needed for authentication, authorization, and encryption. Without proper measure, vulnerability to unauthorized access.
I am Amira Alia with matrix number AI220076. So the next part is case study. In our case study, we have choose two kind of distributed file system, which is first one is network file system. Network file system was released by Sun Microsystem in 1984. It is a file sharing protocol for storing and retrieve files across network. And NFS it is worked by server process data that is requested from NFS client. And then right now we are currently use the fourth version of network file system. In network file system, if one more server is crashed, then the entire server will be go down and crash also. Our second case study is Andrew File System or known as AFS. AFS is facilitate file sharing among a large set of machine, which is it is used for a large of machine. And then the second one, it is primarily used by business for streamlined access to server files across different locations. And all data is stored in file server machine. AFS implement two software components that exist at Unix process called Vice and Venus. The next part, we will see the comparison between network file system and Andrew file system. For the processes in NFS, it is used stateless, and AFS, it is used the stateful protocol. Which is what's the difference between these is in stateless, the server only send the information that the client requested, while in stateful, it is required server to save the status and session information. For the synchronization, NFS use read ahead while AFS it use callback. And then for file caching, it is not provide no provision for local disk caching. In AFS, the entire files are cached on the user local disk. For the scalability in NFS, a small scale between 10 to 20 users, while in AFS it highly scalable as compared to NFS. That is why AFS is suitable for businesses. And then the security in NFS, for NFS, it requires user ID and group ID that are used to determine the file access permission, which is if the user doesn't have user ID or group ID, they cannot enter the NFS, which is network file system. While for AFS, it is used the Kerberos security for verification. Next, NFS target user is for global user, for example, business owner. For AFS, the target user is for group work and large group work. And the last one, for performance and robustness, NFS have network traffic, while for AFS, it is generate less network traffic and highly robust.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hera Amri bin Abdul Rahim, metric number AI220283. In this part, I will explain about our coding. So we managed to create some example of coding as stated in this slide. The provided C++ code introduce a distributed file system class, offering functionalities to manage distributed file system. It employs an order map structure to store file system in containing files with associated content. The class supports creating file system and files, as well as reading the content. Duplicate checks are in place to ensure the integrity of the file system. This implementation serves as a foundation for building and managing distributed file storage. That's all from me. Thank you very much.
In summary, when considering the simulation of a distributed file system with the goal of creating a virtual environment that illustrates how files are stored, accessed, and managed across multiple servers, along with a focus on concepts like data distribution, redundancy, and synchronization in a network setting. The choice between network file system and Android file system is known as comparing the two NFS with its stateless processes, read ahead and delay write synchronization, lack local disk caching provisions. Meanwhile, FS caches entire file locally, making highly scalable. NFS suits smaller scale operation, while FS demonstrates scalability. NFS relies on user ID and group ID for security, while FS utilizes Kerberos Ultimately, the selection between NFS and NFS for a distributed file system simulation hinges on specific use cases, scalability requirement, and the importance of features like security, user-friendliness, and network efficiency. Both systems have distinct strengths and weaknesses, aligned with diverse needs in the realm of simulated distributed file system.